Okay, so yesterday we kind of talked about this, but when we have a bunch of stuff like multiplied together, what do I call that? Term. And a bunch of terms that are added or subtracted together are called polynomials, right? And yesterday we said like if there's like something on the bottom here, it's still one term, or if it's got parentheses, that makes it one term. But let's say we have 2y cubed minus 4xe to the third. Alright, so this is how many terms? 1, 2, 3. So this is called a polynomial. One thing I didn't mention yesterday, what's the number on the front of the term called? This doesn't come up that often. It's called, but it does come up sometimes. A coefficient is what they call it. Coefficient. So, like that word will come up when we get to quadratic formula. Those numbers in front are important. See how far your memory goes back. What's a 3-term polynomial called? Trinomial. Did you get it out of your book or out of your memory?
It's just like a tricycle.
Your dad made you study in the summer?
No, like he didn't do it that long. It was like one day.
No, well, so still.
So now you really.
But you might have saw it one day this summer.
I love smart women.
Okay, what's a 2-term polynomial called? Binomial.
Oh wait.
What's a 1-term polynomial called? Monomial. Yeah, this means 3, like tricycle, bicycle. Mono, the only words I could think of. Oh, there you go. Monotone, I didn't think of that. Monopoly means like one person owns everything. I thought of monocle.
Oh, that's what they gave monochrome. I was thinking that one is used. Monopoly.
Monopoly is a word outside. It was a word that predates the game. It just means it's illegal in America to have a monopoly, which, like once upon a time, Microsoft owned too much of the computer world, so they said you have to split because they had a monopoly.
When they split,
That's not funny.
I don't know how it worked. Yeah, you could Google it.
don't get easy.
Kind of forgot what I was talking about. Okay. Anyway, bicycle. So if it's more than 3 terms, you just call it, and that does happen once today. So it's just called a polynomial. There's no name for it, so just call it a polynomial again. There's no special word. Also in Algebra 1, degree. So the degree of a polynomial, you look at each term to find their degrees. So the degree is like all the powers added together in each term. So what's the degree of the first term? Okay, what's the power right here?
1
and 1. So what's the degree of this term? 4. What's the degree of this term? What's the degree of this term? So for the polynomial degree, you use the largest of the terms. So it would just be a 4-degree polynomial. Does that make sense? Okay, pretend like you know what's going on. Yeah, I'm on the wrong page. Okay, also before we jump in, let's review here. They're kind of shoving a bunch of stuff in together in this lesson. They're fast forwarding our Algebra 1 stuff, but what would this equal? 7x to the third. So notice the exponent does not change when you're adding and subtracting. You have to have like term. What if I did 7x cubed plus 5x squared? Doesn't simplify. Because what's the rule when you're adding and subtracting? Yeah, like terms only. You can only add and subtract like terms. Okay. Now. Now what? Okay. This is a bunch of stuff multiplied together, right? That means times, that means times. So, does order of multiplication matter? No. So we can multiply whatever we want. 2 times 3.
6.
Okay, this is the real part that I want to see if you remember. X to the third times x squared. X to the fifth. Okay, because this kind of means x times x times x. X to the third means that. And this means x times x. And if you multiply them together, what do you got? X to the fifth. So you just, x times x, you add the exponents. Alright, how about this? Cubed.
2x to the 12. Wait, no. 8x to the
Okay, if I wrote it out in like long form, it'd be 2x to the fourth times 2x to the fourth times 2x to the fourth. So what's happening to the 2 is 2 times 2 times 2. The 2 is being cubed. So what is 2 to the third?
8.
8. And it's x4 times x4 times x4. So it's like 4 plus 4 plus 4, or 4 times 3. Do you guys remember that? So it's just multiplying in this case. Okay, this confuses people. This is adding x times x. This is multiplying power to a power. Okay? That's where people get it screwed up when they go back and forth between those two. Okay. How about x to the fifth divided by x squared? Remember that one? X cubed, yeah. What happens, x to the fifth is like this, and x squared is like this. And when you have multiplied values that are divided, they like cancel out. Kind of like reducing a fraction. They cancel out. So it's like subtracting. So it is x cubed, yes. But what if I flip it upside down?
It's just x to negative 3.
Okay, x to the negative 3, yes, that is a thing. But what does a negative exponent mean? Okay, it means, well, it's kind of this, but upside, I don't think I can flip it. It's still doing the same thing, but what does it mean? It means x to the third, but what? It's on the bottom, it's in the denominator. So x to the negative third, or you could call x to the negative third over 1, right, is like 1 over x to the third. You guys remember that?
Yeah.
I think if I remember right, there's only one problem that your answer ends up with a negative exponent. And they did go ahead and change it to, usually the directions tell you to flip it if it's like only positive exponents. Okay. I think I got it. All right, let's do your guys' favorite game and go around the room. Does anybody want to volunteer for number 1? I'd say it's the easiest, but we still might get it wrong, so I'm not going to say that. All right, hopeful. It annoys you, and that amuses me. That's probably okay. Anyway, number 1. What is the degree?
1.
No.
2.
2. Why is it 2?
Oh, because they add.
Yeah, you add the powers. So there's an invisible 1 exponent on the x and the y. So the degree is 2. And what kind of polynomial is it?
Is it a monomial?
Yes, monomial.
I just put mono.
Nah.
Just put them. It's
Okay, number 3.
Sorry.
Okay, but when it comes back around, it might be hard. All right, Shannon. Let's start with Shannon. What's the degree on number 3? 6, yeah. Usually they put the biggest term in the front, but not always. But yeah, the front has a 3, a 2, and a 1 on the exponents. So 3 plus 2 plus 1 is 6. And what kind of polynomial is it? Trinomial. 3 terms. All right, Grant. Number 9 or 5. I mean, what do you think the degree is on that?
1.
It is, well, 9 is kind of like what you really need is an exponent on the variable. So the 9 by itself doesn't really count. Like we haven't been counting an exponent right there. You only count them on the variables. So it's kind of like an x to the, there's like nothing out there. So the degree is actually 0, comma, what kind of polynomial is it?
It's not 1.
It is 1.
Oh,
It's at least a monomial.
oh yeah, I was thinking of the 0.
Okay, number 7. And remember I said if it has more than 3 terms, just call it polynomial. Okay, 7 is an adding problem, and what do we need to remember when we add different terms? You can only add or subtract
So
like terms. So Eli, on 7, what should we do?
2x squared plus 5x squared. So that should be 7x squared.
Okay, keep going.
Then you add 3x and 9x. Well, you do 3x and 9, negative 9x, so that would be like negative 7. So it would be 7x squared minus
Hold on.
6x.
Yeah, there you go. So it's 3x plus negative 9x is negative 6x, right?
Yeah.
Okay. Whoops. So minus 6x. And what?
And then you put negative 8 and 2 together to get negative 6.
Okay, negative 8 plus 2 is negative 6. All right, I'm not going to do 8, but I do need to point something out. On 8, we would do 5a cubed minus 4a cubed. But what about the b's? It would be negative b what? Minus 2b. Because that minus goes on everything in the parentheses on the right. So it's negative b minus 2b for the b's. Okay, number 9. Caden, what do we got on number 9? So I see a, let's see, 12c squared. Does anything go with that?
No, so that just stays as
So
well.
we'll just keep that the
And
same.
then it's 9 CD, and then it's negative 3 D squared.
Yeah. So there's 9 CDs and a negative 3D squared. Pretty much the same as number 7. This thing didn't go with anything now, so we just kept it the same. Number 11, Forest. All right, what happened? It's kind of an important switch. What happened on number 11?
Just add the exponents.
Yeah, well, we switched to a multiply problem. So 6 times 9 is 54, and then what are we going to do with the exponents?
A cubed. Just
Add them. So remember, when it says a, that's like a to the first power. So a2 times a1 is a3. And how many b's do we got? b3 also, b cubed also. All right. 13, Willow. Is 13 the same as number 11? No, it is not. This is where people start screwing up. 8.
4, 8, 6, B2.
Okay, yeah. 2 squared, so you do 2 times 2 like a normal exponent, is 4. Is that somebody's phone on the wall? Okay, A, she said 6 because what'd she do? Multiplied. And then she said B squared. So it's kind of like 1 times 2, but it's just B squared. Alright, Shelby. Shelby, is 15 more like number 11 or more like number 13? Yeah, it's more like 11 because you're just multiplying 2 different things together. So 8 times 4 is 32. How many A's do we got? 3. So A cubed. How many B's do we have? 4. All right. We saved the B section for Anya because I know she likes the harder ones. Okay, now. Actually, how about let's do this. I'm going to give you like half a minute. Why don't you guys like write the answer you're going to guess 17. I know you haven't seen something quite like this. Maybe not even in Algebra 1, possible. Close to something like this, but maybe not. Why don't you, like, off to the side of your paper, guess what you think we're going to do for 17. Okay, so you can do 4 times 5, just like the other problems. It's just a multiply problem. It's 20. Anya, normally when we do x times x, what do we do with the exponents?
We keep them the same.
No, that's when we keep the exponents the same when it's an addition problem. Okay, that would be
So we add the exponents.
add the exponents. Now, can we add n and m together? No. So what we're going to do is just put x to the n plus m. Anybody guess that one?
Oh, I was close.
Olivia, you got it?
I put in.
N. Well, why is it not in m? Because those are multiplied. So I'm not sure you ever saw anything like that in Algebra 1. I know we didn't do exponents like that in geometry, but that might be new. But notice I didn't really use a different rule. We're just putting letters where numbers used to be. Okay, 19, Ava. So should we be adding exponents or multiplying exponents? What do you think, Ava?
We should be subtracting.
Well, okay, normally we would subtract if it was like this. But what's the difference between this and what they have a 19?
It's not the same.
They're not the same letters. So we cannot subtract, we cannot simplify inside the parentheses. But what can we do with that 2n exponent that's outside the parentheses? What should we do with that?
Multiply it into the equation.
Yeah, multiply it. So the top's going to get it and the bottom's going to get it. So on the top, it's 2 times 2n, which is 4n. So that'll be x to the 4n on top. And on the bottom, it's going to be what? B to the... Ava, what would it be?
6.
Right. Yep. Okay. Now, is that going to reduce at all? What do you guys think? Okay. No, for the same reason we just talked about it. These could subtract because they'll like cancel out. But x and b, those don't reduce. Kind of like when you reduce a fraction. Those don't. So no, that's all you can do. Not much. Sometimes there's not much to do. 21. All right, Issa. Let's start with the top, I guess. What should we do on the top, Issa?
21.
Yep.
You multiply the exponent.
So what would the top become?
X
Try again.
Oh, no, 6.
X6Y.
3.
Okay, and the bottom, doesn't look like we can do anything on the bottom right now. So now what? Yeah, this would be a subtraction thing, right? Because we're dividing. So what do I get?
Minus 3.
Yep.
So 3.
So it's x cubed. And what?
3 plus 5.
Right, 3 minus negative 5 makes a 3 plus 5. So it's y to the 8. Okay, I didn't write it, but those are both on top. It's kind of like over 1, but you don't need to put anything over 1. You guys got it? Kind of tricksy. 23. Okay, Olivia, what do you think we should do first on 23?
Multiply, or do the 2 square.
Yeah, yes, do the exponent on the left term. So 2 squared becomes what? 4. So we got 4x to the, what?
Oh, square, or 4.
4y to the 10. And then over here we got plus, doesn't look like we can do anything to that, this term. Is there anything else we can do to this? Can we add those together? Yeah, yes we can. They are like terms, they're both x4. We have 4 of these plus 6 of these makes 10 of those. Same thing. We're back to where we started. Hope. Yeah. What kind of problem does 25 look like? We haven't seen one of these today. You remember the word? Alright, I'll open it up. What kind of problem does this look like, guys? Algebra 1 too far away? Starts with a D. Distributive, yeah. Because can I do anything in parentheses here? No. But can I multiply this? Yes. If you distribute it out like that. So what is 3a squared times 2a? Try again. 6a cubed. So we are adding exponents, right? There. 3a squared times 4x. 12a squared x. We can't really do anything with the a squared x. Just leave it. And 3 times negative 9 is negative 27. And don't forget the a squared. Usually on distributive problems, or basically always, you can't really simplify this because they're all